Okay, so I'm going to go through some of the practice problems from the worksheet that's posted on Google Classroom. I'm going to do numbers 1, 2, 3, and 4. So if you took a look at number 1, you would realize, or hopefully you realized, that this is the parent function. So when we go to vertex form, which will be not next class, but the class after that, we'll be talking about transformations. And so this is the parent function for quadratics. So I'm going to turn on my document camera. And we're going to go through how to graph from your practice problems. All right, so number 1 is y equals x squared. So this is easy, right? Because we only have an a value. So a is 1, b is 0, and c is 0. So that's pretty easy. This value tells me that my graph is going to open up. If c is 0, that means it's going to go through the origin because that's my y-intercept. So yeah, let's see what we can do with this. So the first thing I need to do is find my axis of symmetry. And remember that is negative b over 2a, right? So x is equal to negative b over 2a. B is 0. So x is equal to 0 over 2, which is 0. So my axis is, my axis of symmetry is my y-axis. And I'm going to have a minimum value. I don't know what it is yet. Yes, I do. But still. So here's your axis of symmetry. It's your y-axis. So now I'm going to find my vertex. So I have y equals x squared. Well, x is 0. I just found that, right? This is your x value of your vertex. So y is equal to 0 squared. So y is also 0. So your vertex is 0, 0. So it's at your origin. So now I know that my parabola opens up. So I have a minimum value. And my minimum value is the origin. So therefore, I don't even have to use the quadratic formula or anything to figure out that I'm going to have one root and it's my origin. So that does not help me graph this parabola. Also, my c value is 0. So I have to make a table because I can't use anything else to help give me the shape of this parabola. So I'm going to make a table. So I have x, then I have x squared, and y. And I know that my vertex 0, 0 needs to be that middle value, because that's your vertex. And what I'm going to do is I'm going to pick negative 1, negative 2, 1, and 2. Okay? So now I can substitute negative 2 into x. So negative 2 quantities squared. So negative 2 squared is 4, positive 4. So I know that this is symmetrical. So if I'm 2 units away and I'm at 4, then I go 2 units away and I'm at 4. Also, 2 squared is 4. So that's a good check. So now I'm going to do -1. So -1 quantity squared is 1. And it's the same thing for this point. So now I can plot those points. So I have -2, oops, 1, 2, 3, 4, 5, 6. Actually, I can just do 1, 2, 3, 4. Just bear with me. So this is 1, 2, 3, 4. So -2, 4, and then +2, 4, and then -1, 1, and +1, 1. And here's your parabola. Again, ugly parabola. Don't judge me. So we have our minimum value at 0, right? Your minimum value is at 0. Our domain is all reals, or -infinity, +infinity, however you want to write it. And my range is y is greater than or equal to 0. Alrighty. So that's number 1. So number 1 was a good start because it was the parent function. So it was pretty easy. All right, let's look at number 2. So number 2, we have y is equal to x squared plus 2x minus 1. So first step is a is 1, b is 2, and c is -1. So I know that my graph is going to open up. I'm going to have a minimum value. And I also know that it's going to it's going to intersect my y-axis at -1. So let's find our axis of symmetry. And remember, I do that by finding -b over 2a. So x is equal to -b over 2a. So x is equal to -2 over 2 times 1, which is 2. So my axis of symmetry is at -1. So I can start to make my graph. I don't know how far up or down. Well, no, I don't know how far up or down I need to go yet. But what I do know, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, 6, 2, 4, 6. But what I do know is that my symmetry line is at -1 on my x-axis. So here is your symmetry line. Okay. So let's find the vertex. So I have y equals x squared plus 2x minus 1. Well, x is -1. So y is equal to -1 squared plus 2 times -1 minus 1. All right. So y is equal to, so -1 quantity squared is 1 plus 2 times negative 1 is negative 2 minus 1. So 1 minus 2 is negative 1. Negative 1 minus 1 is negative 2. So my vertex is at negative 1, negative 2. So negative 1, negative 2. There's your vertex. So it opens up, right? So it will cross through my x-axis. So I can check my roots. So let's find our roots. So x is equal to negative b, so negative 2 plus or minus the square root of 2 squared minus 4 times a times c over 2a. So x is equal to negative 2 plus or minus 4 minus 4 times 1 is 4. 4 times negative 1 is negative 4. So this is going to be 4 plus 4 over 2. So I have, I'm going to have an imperfect square here. So this is not going to be perfect. So my roots are going to be x is equal to negative 2 plus or minus radical 8 all over 2. Well, radical 8, I can simplify radical 8, right? Because it's 4 times 2. So I can take the perfect square 4 out. So I get negative 2 plus or minus 2 rad 2 over 2. Oh, sorry. I didn't know you couldn't see that whole time. So now look, negative 2, 2, and 2, I can simplify all of that. So negative 1 plus or minus radical 2. That's my root. I can't graph that. So I need to make a table. I do know, though, that my y-intercept is at negative 1 on my y-axis. So that means that this point is also going to have a negative 1. So I just found 0, so I don't want to use, oh yeah, I found when y was 0. So let's find out what happens when x is 0. Oh, that's your y-intercept. Duh, green, white, get with it. So let's choose the point 1 when x is 1. So we're going to make a table, but I already have one of my points here. So I just have to do one more point, right, to get this point right here so I can graph it. So I have x, and then x squared plus 2x minus 1, and then y. So we did our vertex, which was negative 1, negative 2. So there's your vertex. We know that when x is 0, y is, sorry, 0 goes over here. Wow, it's a day, guys. So negative 2, y is negative 1. So I need negative 3. Okay. So I have the quantity of negative 3 squared plus 2 times negative 3 minus 1. So negative 3 quantity squared is positive 9, plus 2 times negative 3 is negative 6. So I have 9 minus 6, which is 3, and then 3 minus 1, which is 2. So at negative 3, so 1, 2, 3, at negative 3, I have a value at 2. And at 1, I have a value of 2. And there's your parabola. Okay, so we found the roots. The roots were not graphable. So I used a table, but I already knew my y-intercept, so I didn't have to do the math for that. And I needed one more point, so I chose negative 3. All right, so for this graph, your domain is all reals, and your range is y is greater than or equal to negative 2. Okay, so that's number 2. Let's take a look at number 3. All right, so number 3, we have negative x squared minus 8x minus 17. Whoops, so y equals, sorry guys, y equals negative x squared minus 8x minus 17. So my a value is negative 1. So my parabola is going to open down, and I'm going to have a maximum value this time. My b value is negative 8, and my c value is negative 17. So this is one of those instances where we're probably not going to graph the y-intercept unless your vertex is close to negative 17, which I don't know yet. So we're probably not going to be able to graph that y-intercept, but let's check out our axis of symmetry. So I have x is equal to negative b over 2a. So x is equal to negative b. Well, b is negative 8, so the opposite of negative 8 is positive 8 over 2 times negative 1, which is negative 2. So 8 divided by negative 2 is negative 4. So that's your x value of your vertex. I don't know how far up or down I need to go, but I do know I have to go all the way to negative 4. 1, 2, 3, 4. So here is your axis of symmetry. Okay, and we also know that that's your x value for your vertex. So let's find the y value for your vertex. So we have y is equal to negative x squared minus 8x minus 17. So this negative value, this negative x squared, remember that is negative 1 times x squared. Okay, so remember I kept making a huge deal about this in the beginning of the year. This is why, okay, because it's going to throw your whole answer off if you don't do that. So negative parentheses 4 squared, negative 4 squared minus 8 times -4 minus 17. So y is equal to -16 plus 32 minus 17. I believe this is going to be 1. But we know I don't trust my basic math. -16 plus 32 minus 17, -1. Well, good thing I didn't trust my basic math. So y is equal to -1. So my vertex is at -4, -1. So -4, -1, and my parabola opens down. So if my parabola opens down, I don't even need to find my roots because they are not going to be real roots. If you were to use the quadratic formula for this one, you would get the square root of a negative number. So I'm not even going to try to find my roots because they're not real. They're imaginary roots because this is below your x-axis and it opens down. That's how I know that, right? So this is my maximum value. I'm not even going to cross my x-axis. So I need to make a table. So I have x, and then I have -x squared minus 8x minus 17, and then I have y. So my vertex is at -4, -1. So here's my vertex. So I want -5 and -6 and -3 and -2. Okay. So remember how I said it doesn't matter, you're going to get the same math? Well, I like working with smaller numbers better. So if I find my value at -2, I'll know my value at -6. And if I find the value at -3, I'll know my value at -5. So I'm going to find my values for a -3 and -2 because I like working with smaller numbers. So if x is -3, I have -3 squared minus 8 times -3 minus 17. Again, I don't trust my simple math. So -3 squared is +9, but it's -9 because that negative sign, plus 24 minus 17, and I get -2. So that means I have a point at -3, -2. 2, 4, 6, 8. So that also means, sorry, pretend that doesn't exist. So at -5, I have a point at -2. Okay, this looks like it's a point, but it's not. I just messed up my interval there. All right, so now let's find out when it's -2. So -2 squared minus 8 times -2 minus 17. So -2 quantity squared is 4, but it's -4. -4, all I can hear is my daughter, plus 16 minus 17 is -5. So now I know that at -6, it's also -5. So -2, -5. So 2, 4, 5. And it's the same over here. And here is your parabola. Okay? So your domain is, again, all real numbers. and your range is y is less than or equal to -1. Okay? So that's number 3. And the last one I'm going to do for you is number 4. So number 4, we have -2x squared plus 4x plus 1, and that's equal to y. Keep forgetting to do that. All right, so let's list out our values here. So A is -2, B is 4, and C is 1. Okay, so my parabola is going to open down. My y-intercept is at 1. So what that means is it's going to sit above my x-axis because it opens down and it's at 1 on the y-axis. So I'm going to intercept the y-axis. So let's first find our axis of symmetry. And that is x is equal to -b over 2a. So b is negative, b is +4. So -4 over 2a, so 2 times -2. So -4 over -4 is 1. So my axis of symmetry is at x equals 1. So that's your axis of symmetry. So let's make that. It helps me visualize what the graph will look like. So it's just something that I do. All right, so x is equal to 1. So here is your symmetry line. Okay. So now let's find the vertex. So I have y is equal to -2x squared plus 4x plus 1. So I'm going to substitute in with a 1. So y is equal to -2 times 1 squared plus 4 times 1 plus 1. So I have -2 plus 4 plus 1. So -2 plus 4 is 2. 2 plus 1 is 3. So y is 3. So our vertex is at 1, 3. So let's do 1, 2, 3. So this graph is going to be really thin. So 1, 3. So I know my y-intercept is at 1. So, and that's 1 unit away. So 1 unit away on this side. All right. So let's see. I don't think I'm going to have real roots. I'm going to have real roots. I don't know if I'm going to have integer roots, I should say. So let's just check that out. Let's see. Let's see if we have integers. So I'm going to find my roots. So I have x is equal to -b, so -4 plus or minus the square root of b squared, which is 16, minus 4 times a times c over 2 times a over -4. So x is equal to -4 plus or minus the square root of 16 plus 4 times 2 is 8. And then 8 times 1 is 8. So 16 plus 8, so 24 divided by -4. So 24 is not a perfect square, so my roots are irrational, so that's not going to help me. So I need to make a table. So on my table, I have x, and then I have -2x squared plus 4x plus 1, and then I have y. So my vertex is going to be my middle value, so 1, 3, but then I also know 0, -1, 2, and 3, that at 0, because of my y-intercept, this is my vertex, my y-intercept is at 1, so that means that at 2, my value is also 1. So now all I have to do is find my value when x is -1. So -2 times -1 squared plus 4 times -1 plus 1. So -1 squared is 1. 1 times -2 is -2. So I have -2 minus 4, so I have -6 plus 1 is 5. So that means, wait a minute, is it -5? Hold on. 1 squared, so -2 plus -4 is -6, so it's -5. Greenway, you dropped your negative sign. I was like, wait a minute. 1, 2, 3, 4, and 5. Awesome. 1, 2, 3, 4, 5. So -1, -5, and 3, -5. So the reason why this parabola looks so thin is because I had really small intervals on my x-axis, but really I had larger intervals on my y-axis. So that's why this parabola looks funny. Well, I also can't draw. Okay, so hopefully this all makes, oh, sorry, my domain. Can't forget that. So my domain is all real numbers, and my range is y is less than or equal to 3. Okay, so hopefully this makes some sense to you and you understand it. I do have the answer key up on Google Classroom for you to check the other ones that you may want to try to graph. And then you have the flip grid. All right, guys, you know where to find me if you have any questions or if you need help or if you want to set up a Google Meet. We won't have another math class for a little while because next week math only meets once and we're doing STAR Math. So it won't be until the following week. All right, lovelies, we do have a meet today at 1, so I will see you there.